Fat is an advantageous reserve fuel for flight compared to carbohydrates and proteins. A unit of fat provides as much energy as an equivalent amount of carbohydrates and proteins combined. For instance, 1 gram of fat provides approximately 9,300 calories, while the same amount of carbohydrates yields only 4,200 calories, and 1 gram of protein offers only 4,100 calories. Normal conditions do not suggest the utilization of protein as a fuel source for muscular work in pigeons, except in extreme cases where fat and carbohydrate reserves are completely depleted. To further support the claim that fat is the major fuel for racing, experimental studies on the muscles of racing pigeons have shown significant findings. After just 30 minutes of muscular activity, the amount of fat circulating in the bloodstream of exercising birds increases by nearly 18% compared to non-exercised birds. Additionally, the amount of fat in the major pectoral muscles of exercised birds increases by 25 to 40%, and in the liver by almost 30%. Interestingly, the amount of fat in body fat depots located under the skin and within the abdomen decreases by approximately 25% during exercise. These observations indicate that fat from various body depots is mobilized and transported via the bloodstream to the liver and working muscles as a necessary fuel for muscle activity during flight. Within the red muscle fibers, mobilized fat is transported to the vicinity of the mitochondria, where it can be readily metabolized to provide the energy required for ongoing flight. The breast muscles, which contain an extensive network of tiny blood vessels surrounding each fiber, serve multiple purposes. Apart from replenishing fuel supplies for the muscles, these blood vessels also provide a rich supply of oxygen, crucial for the fat-burning process known as aerobic metabolism. Additionally, the network of vessels aids in dissipating heat generated by working muscles, carrying it to the lungs and mouth, while also removing carbon dioxide and other metabolic waste products. Another advantageous byproduct of fat metabolism is the production of water. The burning of 1 unit of fat generates 9 units of water, which is highly beneficial for the bird during long flights. In contrast, white muscle fibers contain very few mitochondria and, consequently, minimal amounts of fat. Instead, the primary fuel for white fibers is glycogen, which appears as dark granules under electron microscopy. White fibers are responsible for executing rapid movements and therefore require a readily available fuel source to provide instant energy, and glycogen fulfills that role. As the metabolism of glycogen to glucose in these fibers does not require oxygen, it operates via anaerobic metabolism, obviating the need for an extensive network of blood vessels or numerous mitochondria, as fat is not utilized. Based on the information presented, we can outline the likely sequence of events in the working muscles of pigeons during a race. Before release at the race point, the white fibers are loaded with glycogen, while the red fibers contain ample reserves of glycogen and fat, their primary fuel. Fat storage depots in various areas of the body hold sufficient reserves for the demanding hours of the race, without causing the birds to be overweight. There is a balance between body fat content and the physical condition of the birds. The liver also possesses adequate reserves of glycogen and fat that can be mobilized and transported through the bloodstream to the working muscles when needed. These preparations ensure the birds are well prepared for a distance race. Although slightly heavier birds may be at a disadvantage in normal races, their extra fat reserves can prove beneficial in challenging races. Thus, everything is set for the race. As the birds are released, the explosive burst of muscular effort propels them into the air at an attack angle of approximately 30 degrees, with a maximal climbing velocity of around 5 miles per hour. Their wings beat an average of 9.4 times per second, creating a figure-8 pattern with the body as they sweep through an angle of 142 degrees in one beat. The power of the breast muscles is immense, with one of the major pectoral muscles capable of exerting a force roughly 10 times the weight of the bird. The downstroke occupies about 1/3 of each beat, while the upstroke takes up about 2/3. The launch requires tremendous explosive power, and although the white fibers alone are typically responsible for this action, they constitute only 6% of the total fibers in the breast muscles. It is unlikely that only 6% of the fibers could handle the substantial workload involved in such a powerful action. Therefore, it is highly probable that both red and white fibers cooperate, contracting rapidly to propel the birds upward, allowing them to gain height and reach their cruising speed. Experimental evidence has demonstrated that within minutes after release, all glycogen reserves in the white fibers of pigeons are completely depleted, causing their activity to cease temporarily due to fuel exhaustion. In fact, these experiments have revealed that glycogen stores in the white fibers are entirely depleted within the first 10 minutes of exertion. As the birds reach their cruising speed, the number of wing beats per second decreases from the initial explosive rate of 9.4 to approximately 5.5 beats per second. At this point, the red fibers, which are now solely responsible for the work, continue to be loaded with glycogen, a notable difference from the white fibers, and, importantly, contain substantial reserves of microscopic fat droplets. These fat droplets, located near the mitochondria where they are utilized, undergo oxidation or chemical burning in the presence of oxygen. This process releases a high-energy compound called adenosine triphosphate, ATP, which can be likened to the steam generated by a locomotive. Just as steam powers a locomotive, ATP derived from fat burning provides the energy to sustain the wing's average beat of around 5.5 times per second during flight for several hours. Initially, the angle formed by the sweep of the wings during launch was approximately 142 degrees, but during cruising speed, it decreases to around 85 degrees. The powerful downstroke during fast flight provides lift and strong forward propulsion, eliminating the need for a forceful upstroke and allowing for a decreased wing angle of approximately 85 degrees. This efficient system continues to operate throughout the duration of the race, assuming the muscles have been adequately conditioned to handle the distance and weather conditions. Notably, evidence suggests that once cruising speed is reached, wing beats continue rhythmically and automatically through reflex action centered in a small area of the spinal cord. This implies that the basic wing beat rhythm during flight operates automatically, without conscious effort or will from the birds. Additionally, it is worth mentioning that not all the red fibers in the major pectoral muscles are active simultaneously. Instead, evidence suggests they work in shifts, allowing some fibers to rest and replenish fuel supplies from body depots through the bloodstream, while the majority continue working. Recalling the earlier findings, within 30 minutes after release, the amount of fat in the major pectoral muscles increased by up to 40% compared to resting birds. By 2 hours, the fat content had increased even more, reaching approximately 85% higher than the resting muscle fat levels. At the 5-hour mark, the fat content had increased by nearly 170%, over 4 times the amount found in resting birds' muscles. These findings once again emphasize the crucial role of fat as a primary nutrient in fueling working muscles, highlighting the bird's heavy reliance on this energy source. The evidence speaks for itself. As the day progresses and the miles pass, the fittest birds lead the way, either individually or in various sized flocks. Fat is continuously mobilized from body depots and picked up by the bloodstream, delivered to the massive pectoral muscles that work rapidly and efficiently. Less fit birds lag behind, forming smaller flocks and trailing behind for miles. The hours spent in flight will take their toll, and it is inevitable that some birds will not make it home before nightfall. Free racing pigeon tips and lots of info. Please subscribe to my YouTube channel. Look at the links and email below. There are many reasons to buy my racing pigeon method. Here are some of the best reasons. You will get excellent results. It's a very simple system to use. It's affordable. I have had over 400 first prize winners. It's adaptable to any situation. You can use it with any racing method, natural, widowhood, young birds. It's a very effective method. There is no need to spend a lot of money on fancy pigeon products. It's a reliable system and it is foolproof to use. Professional athletes, race horses, take the same products. There is science behind this, not just hearsay. It is all to do with red blood cells and oxygen in the blood. Without that, a pigeon will not race well, or an athlete will not win a race. If he has low oxygen in his blood, the above is fact and is 100% science. There are a few things you can do to improve your chances of winning at racing pigeons. One of the most important things is to learn as much as you can about the sport. You'll need to know the different types of pigeons, how to train them, and how to race them. Another key factor is practice. You'll need to be able to fly your pigeons competently in order to win races. And, of course, you'll need to have the funds to invest in racing pigeons and other racing equipment. Free racing pigeon tips and lots of info. Please subscribe to my YouTube channel. Look at the links and email below. There are many reasons to buy my racing pigeon method. Here are some of the best reasons. You will get excellent results. It's a very simple system to use. It's affordable. I have had over 400 first prize winners. It's adaptable to any situation. You can use it with any racing method, natural, widowhood, young birds. It's a very effective method. There is no need to spend a lot of money on fancy pigeon products. It's a reliable system and it is foolproof to use. Professional athletes, race horses, take the same products. There is science behind this, not just hearsay. It is all to do with red blood cells and oxygen in the blood. Without that, a pigeon will not race well, or an athlete will not win a race. If he has low oxygen in his blood, the above is fact and is 100% science. There are a few things you can do to improve your chances of winning at racing pigeons. One of the most important things is to learn as much as you can about the sport. You'll need to know the different types of pigeons, how to train them, and how to race them. Another key factor is practice. You'll need to be able to fly your pigeons confidently in order to win races. And, of course, you'll need to have the funds to invest in racing pigeons and other racing equipment.